Welcome to a lesson with Dr. Powell. Let's take a look at block multiplication of matrices. But first, let's take a look at the column interpretation of what it means to multiply these two matrices together. We take the first column in this matrix right here, and these represent scalars, which we can use on these columns in such a way to get the column in the product here. Similarly, the second column right here, we can use these as scalars in a linear combination of the columns here with a 0, 1, 1, and add these together to get this right here. And similarly over here, I mean, loosely thinking, this just simply means add all these columns together to get that. This means add the second two columns to get that. And this means add the first and the last column to get that one. Okay, now let's look at how we can block up this process a little bit. First of all, you look at these linear combinations. What if we took the first two things in each linear combination? All right, just the first two. Think, guys. The result of what we get in for each column that we have from just the first two bits in each linear combination, then added to what we get in each column right here, here, and here, should give us our final result if we just kind of split it up that way. For instance, we could write this as, let's just look at the sum of the first two, or the linear combination of the first two columns that we have with a 1, 1, 0, 1, and a 1, 0 right there. So for the first guy, we're just adding those two together. And so we could think, okay, that would be what? 2, 1. Yeah, so 2, 1 for that guy for the first column. Now for the second column, let's see, that's from here. Just using the first two bits, we have just a 1, 1. And for the third column, just focusing on the, the third column of the final result, all right, which is right here. We just focus on the linear combination part of just the first two columns, and we end up just getting 1 times that plus 0 times that. So we end up getting just 1, 0. Okay, now if we add to the results that we got from the first two bits of each linear combination with the parts that we get from the last bits, all right, that would be, let's sync. Well, it's just exactly what it reads, just negative 1, 0. Here, this is negative 1, 0. And this over here is, again, so just a negative 1, 0. So it looks like we had a 1, 1, 1 in each part right there. Now if we go ahead and add this together, notice what happens. We end up getting in the first entry right here, 2 minus 1 is 1, 1 minus 1 is 0, 1 minus 1 is 0, and then 1 and 0, and 1 and 0 gives me a 1, 1 there, and a 0, 0 gives me a 0. So notice that the result of this matrix multiplication could have been split up into parts. First do this part right here, like the first two parts of each linear combination. And then last, do the last part. Now we can actually do this dividing up thing by just thinking about this. So the first two parts of each linear combination comes from the first two columns. And the scalars that are associated with those columns are right here. And then right here, I have, okay, so then the last column has these scalars associated with it. If I labeled this as like an A and a B, and this as a C and a D, then the result would be simply AC plus BD. So this part, these columns relate to the first scalars. The first columns to the first scalars in the linear combination. The last column to the last scalars. And so what is the matrix multiplication AC? That's simply taking linear combinations. So just so these linear combinations of those columns right there, but we also need to finish off linear combinations so we add to each one of those combinations a combination that we get from here, from this matrix multiplication where we are actually taking, so we So right here, see this 1? It's only one thing to do. 1 times this guy gives you your first column of D. So that's a pretty easy multiplication here. So 1 times that column is just that. 1 times that column is just that, and so forth. And so really what we end up getting is we can break up one matrix multiplication into smaller matrix multiplications and then add the results together. And the process is we partition the columns and we use the exact same partition of the rows. So let's look at a simpler example. What if we had something like 1, 0, negative 1, 1? And we can do 1, 1, 0, 1. Okay, so let's divide the columns of this matrix and use the exact same partition over here in the rows. So then what we do is the result is going to be the result is of multiplying this matrix to this one, which is just simply a 1 times that column. It's just 1. In fact, the result here you could realize is going to be just a number. It's going to be an R because the codomain here is an R. And so in the column interpretation, the output should be an R as well here because we're inputting a single vector. So this is going to be 1 times that guy, so 1. And then plus, well, you see this right here. So we're going to take, so this is like an input vector into this little matrix right here with a 0 and negative 1. So we take 1 times a 0 plus 0 times a negative 1, which is just 0. So literally we're taking this matrix times that one. Plus, and then we can do this matrix times this one, 1 times 1, which is 1, and we end up getting 2 as the result. Now we could have done this in different ways. We could have divided this as follows. So this 1, 0, negative 1, 1, we could have divided it up like that, just 2 separate spots like that. Or we could divide it like this, where every single spot has a is blocked off or partitioned off. And you can use the same partition over here. Then if you did that, it would simply be this times this, plus this times this, plus negative 1 times 0, plus 1 times 1. And the result would be, so 1 plus that's 0 in there, and plus 1 would be 2. Now keep in mind, you see this right here? This is actually the result of the middle matrix multiplication that we had up here for the 0 when we had 2 together. We're combining those 2. So in the end, we actually, by partitioning the columns, partitioning the rows in any way we like in such a manner, we can get the same result for matrix multiplication. Really all we're doing is we're just taking like one part of all the linear combinations to get the first guy, and then yeah, so we're just taking the parts of the different linear combinations. Like this right here is take the first part of all linear combinations, and then take the middle 2 parts, then take the last part, and then add all the results together. We just kind of, all we're doing is just regrouping how we're adding things as we get the final result. Thanks for watching.